Hey guys, it's Mr. Decker here once again, and we are looking at Lesson 26, the game design process. We are in the Code.org Computer Science Discoveries curriculum, and we've got a project to complete. By the time we're finished with this one, we will have a working Cake Defender game. Kind of fun. Let's get to it. This is an example of a Defender game that you'll build by the end of this lesson. To defend your cake, move the alien with arrow keys to block the ladybugs and push them into the water. All right. So we've got collision detection. Once I push them into the water, they disappear and they reappear at the beginning of the bridge, which is at the left side of the screen. So X would be 0 or less than 0 to get them back over there each time you push them into the water. If they get to the cake, the score is going down. If I push them out, my score goes up. You can see my score is negative now. All right, so let's see. If I was making this program, what sprites would I need? I'd need the cake, I'd need the alien, I'd need the ladybug. What variables? I'd need a score variable. And then what functions would I use? I'd use a function for my background. I'd use a function for sprite movement and move player, and a sprite for maybe getting the score onto the screen as well. All right, let's continue to Bubble 2. There is a project guide for this project if your teacher made that available to you. But it's already filled out, so no worries there. All right. So right now we have the alien, we have the cake, and we have a ladybug. Let's go back to the code. It says, before you get started, you'll want some better animations for each of your sprites. Do this. In the animation tab are animations for each of your sprites. Go look at what they are. In your code, give each sprite its appropriate animation. Use the ones provided for now, but later you'll be able to change them. So let's get that directions toggle out of our way. And we're needing to set the animation for each of these. So the cake will be cake. Simple. That makes sense. The player will be the alien. And then enemy 1 and enemy 2. Control C, Control V. Ladybug and Control C, Control V. Ladybug. Just like that. We've got them set up. Do we have a draw sprites? Yes, we do. So we run it, and now they're showing up, but my ladybugs are way up here. All right, so I think that's all it wanted us to do on Bubble 3, just to check and make sure. Yep. In your code, give each sprite its appropriate animation. Yep. All right, we're good to go there. Bubble 4. Let's go, Bubble 4. All right. Moving the enemies, you'll need to get your enemy sprites to a random position and moving across the screen. Do this. After each enemy sprite is created, set its X position to 0. So let's see if we can find move player, displace enemies, enemies touch water. All right, so we're going to do this up here. Let's see. So after each enemy sprite is created, set its X position to 0. So we're going to set the X position to 0 for each enemy. So sprite.x, enemy 1, 0, and then enemy 2, also 0. Set its Y position to be a random number between 150 and 250. All right, we can do that. So sprite.y. Oh, you know what? I'm going to move this. There we go. and sprite.y for this one as well. And Control C, Control V, and we're going to go grab a random number block. Put that here. It said to put it between 150 and 250. And we will do the same thing for sprite.y. 150, 250. Simple enough, just following instructions. And then we're going to set their velocity to 2. So back to the sprites drawer, and it's going to be velocity x for each one. All right, so enemy 2, Control V, set it to 2. And then enemy 1, Control C, Control V, and 2. All right, is that everything for bubble 4? Test the program. Your enemy sprite should now be moving across the bridge. So run it. There they go. And they should be in a new location each time between 150 and 250. That's working nicely. All right, let's finish there. Head on over to bubble 5. Now you'll just need to get your character moving left and right and change its animations. Do this inside the move player function. So let's find the move player function. Here it is on line 49. Use a conditional to detect when the right arrow is pressed. So control if world drawer, let's see, key down right. If it is, move the player sprite to the right by 3. So sprites, sprite.x gets sprite.x plus, because we're moving to the right. And this is going to be player plus 3. So we move 1 pixel faster than the ladybugs. That's good. And then use another conditional to move the player left when left arrow is pressed. Okay, so control, world drawer, key down. Oh, thought I grabbed it. Key down left this time. And we need another counter pattern. Player.x gets player.x minus 3. All right, test your game. Your character sprite should now move left and right when you press the left and right arrow keys. And he does. Okay. So it might ask us to do this in the future, but I'm going to go ahead and duplicate. And I'm going to flip these vertically. There we go. And I'm going to call this alien walk left. So now inside these, I'm going to set the animations for the alien to face the direction that I'm telling it to go. So player and player, and we're going to set them so right, alien walk right, and left, alien walk left. So run that. Now we're facing the way we're walking. That's good. All right, and I think that's it for bubble 5. Let's go bubble 6. You want your player to sprite to move up and down as well inside the move player function. So let's go back down to it. Use a conditional to detect when the up arrow is pressed. Move up by 3. Move the player down when the down arrow is pressed. And we'll have them moving by 3 there as well. And then our character is going to be moving in all 4 directions. So control, another if statement, And let's go ahead and build both of these out at the same time. We'll do both up and down to save a little bit of time. So I keep doing that. Key down, up, and key down, down. And then we'll go to our sprites drawer. We're going to grab sprite.y this time because we're handling up and down. Math, to go up, I'm going to be subtracting. And to go down, we are adding to y. Back to the sprites drawer, we're grabbing sprite.y again for both of these. And it's going to be player across the board. And 3. And 3. Run it. Now we can move. And we can really, we can take him anywhere. He can go anywhere. Let's see. Test your code. Your character should now move in all 4 directions. Up, down, left, right, and on diagonals if I'm pressing more than one arrow key. Excellent. Continue. And by the way, the reason why I'm not having to call these things in the draw loop is because they already are. See right here. So move player is right there on line 27. All right. You can change the animation when the player changes direction. All right. Inside the animation tab, copy the animation of your player sprite, flip each frame to the new animation. We already did this back on an earlier bubble. And then rename your new animation. Inside the move player function, set the sprite's animation so the player changes the direction it's facing, left and right. Yep, we did that. So we're done with bubble 7 already. Moving right along, code.org. Moving right along. All right, on bubble 8, if the enemies get all the way across to the cake, you should place them back at the left side of the screen and decrease the score. To start, you'll write code for only one of your enemies. Okay, so if the enemies get all the way across to the cake, you should place them back at the left side and decrease the score. Okay, so right now we already have a score variable up here. So that's done for us. All right, so let's go to the do this. Inside the enemies touch cake function, use a conditional. So go to the control drawer, grab an if statement, put that inside the enemies touch cake function. If it has, loop them back to the left side of the screen. If enemy 1 has touched the cake. So world, or wait, no, that's in sprites, right? Yep, is touching. So enemy 1 is touching cake. Then enemy 1's X is going to be 0, setting it back to the left side of the screen. And then set its Y position to be random. Math, random number, and we're setting that between 150 and 250. And then we're going to use the counter pattern to decrease the score by 2. So in the variables drawer, we're going to grab this one, not the ones that say var in front of them. Be careful about that. We're going to say score get score minus 2. Enter. Let's run it and check and see if that's working for enemy 1. Yep, minus 2. Let's just see one more time. It should be minus 4, and it should be, yep, excellent. All right, let's finish. We'll go to bubble 9. Okay, touching the cake with the second ladybug. Your first enemy sprite should now be resetting when it gets to the cake. Now you'll want the other ladybug to reset as well. Do this. It says inside the enemies touch cake. Oh, I'm all over the place. Inside the enemies touch cake function, you should have written code that resets enemy 1. Copy the entire if statement. Okay. So we're going to highlight this whole thing, Control C. Make sure your cursor is blinking right there. And then we'll Control V. And we're going to be changing the name of the sprite in the code from enemy 1 to enemy 2. So we're going to type enemy 2 here. Control C, Control V, Control V, and then now both should be working. Yep, -4, just like that. All right. They're resetting when they touch the cake. Let's go to bubble 10. Your program now includes code in 2 places to set the enemies on the left side of the screen at a random Y location. You can create functions to reset each of your 2 enemies to remove repetitions from your program, and this will make your program easier to read, allow you to change it more easily, and allow you to quickly reset your sprites at other points in your program if you need to. So do this. It says at the bottom of your program, create 2 new functions. All right. So we're going to go to our functions drawer, 2 new functions. I'm actually going to go here. I'm going to hit enter, show blocks, and I should have some new space down here. So function, we're going to call this one set enemy 1, and we're going to do another function called set enemy 2. And now I should be able to create these spacers. So boom, boom, and here, boom. Show blocks again, and if you want those spaces to be there because it's nice and uniform with the other functions, then I totally understand. I get it 100,000%. Okay. Inside each of these functions, we're going to place code that sets the enemies on the left side of the screen and gives them a random Y position. Wherever the code for set enemy 1 and set enemy 2 appears in your program, replace them with a call to the functions you just created. So we want to copy this code right here. So I'm going to grab set enemy 1, Control C, all of that from lines 47 to 49. Inside that enemy 1 is touching cake. And we're going to put that down here into set enemy 1. So I'm zooming down there with my cursor, Control V. And we're going to grab set enemy 2, Control C. Oh, So I'm not needing to subtract on the score, so we'll fix that. We're actually going to be setting the velocity x. Okay, so remove that, sprites, set the velocity. Enemy 1, enemy 2, velocity is 2. Whoops, Control Z. Oh my goodness, Control Z. I thought I clicked in there. Apparently I did not. 2. There we go. All right. And then it says wherever the code for set enemy 1 and set enemy 2 appears in your program, replace them with a call to the functions you just created. So actually up here, we'll get rid of this code and this code, and we're going to call those functions. So set enemy 1 and set enemy 2. All right. And wherever the code for, let's see, does it appear anywhere else? I guess it appears here. So, whoop, there you go. Set enemy 2 and set enemy 1. And then we'll take these 2 lines out and these 2 lines out. And let's test it. right, so far so good. Appears to be working pretty all right. Okay. Let's finish there and continue. It's time to write code for some more sprite interactions. Your player sprite should displace the enemy sprites. All right, do this. It says, for this level, you'll be writing code inside the displace enemies function. So let's find that. Displace enemies. There they are. Or there it is, rather. Write code that makes the player displace both enemy sprites. So we'll find that sprite.displace. There it is. And this should be rather simple. It's going to be player displace enemy 2 and player displace enemy 1. Oh, wait. They're not capitalized. I messed that up. All right. So enemy 1. I don't know why I capitalized that. Enemy 2. Now let's test it. All right. That's working. Sweet. Let's see. Hint, you can use sprite.debug to see your sprite's colliders if you need to debug your program. For now, I think we're good. So let's finish there. Let's head to bubble 12. Touching the water. The last part of the game that you'll need to write is the code to reset the sprites when they touch the water. Luckily, you should have already written functions that reset each sprite, so you'll just need a good way to know when either sprite leaves the bridge. Start by writing the code for a single enemy and then copy paste and make small changes to create code for your second enemy. All right. Whew, let's underdo this today. All right, for this level, you'll be writing code inside the enemies touch water function. Let's find it. Enemies touch water, right here, line 74. All right, and inside that, we're going to use an if statement to check whether enemy 1 is off the top of the bridge by checking whether its y value is below 140. All right, so let's see. Within your if statement, use your setEnemy1 function to reset the sprite. That's why we did that work earlier. All right. So we're going to say math, and we're checking if its value is below. So I need less than. And sprites, and it's sprite.y. It's going to be enemy1.y less than 140. And then we'll go to functions, and we're just resetting this. Set enemy 1. All right. And then let's see. Use an if statement to check whether enemy 1 is off the bottom of the bridge here. So we need math, and this time we need a greater than, and it's going to be enemy1.y again. And this time greater than 260. And we're going to go back to our functions drawer, and we're going to call that set enemy1 function there. We're also going to add 1 to the score. So let's go here, grab this one, make sure you're not grabbing the vars, make sure you're grabbing the blank one. So score, get score plus 1, and score, get score plus 1. All right, test your program for the first enemy sprite. Make sure the sprite is resetting and the score is going up. All right, they're together here. Oh, score went up. Went up. Score is going up. All right. Once that it's working, copy and paste the codes that you wrote to create the same behavior for enemy 2. You'll need to change the name of the sprite and the name of the functions you use. All right, so let's get that done. So we're going to copy this. So lassoing it, Control-C, Control-V, and then this is all going to be enemy 2. And then set enemy 2 and set enemy 2. Run it, and then they both should work. Yep. Sweet. Both working very nicely. All right, look at me go. No ladybugs are getting to my cake. Never. All right, finish. Continue. At least I think we did everything. Let's go back and check. Going back to check on bubble 12 that I did everything. Once that is working, yep, okay. Back to bubble 13. All right, we've got 4 challenges to complete here. High score. All right. Create a new background that shows up when players reach a good score of your choosing. Turn the background pink when the player gets over 10 points. Okay. Do this. When drawing the background, add an if-else statement to check if the score is above some number like 10. Okay. So where can I put that code? I have a show score function. Where is my background being drawn? Right here. Okay. Game background. Let's see. I need an if-else statement. So we're going to grab all of this, control C. Actually, I don't need to control C that. I'm just going to move it right here. And actually, I did need to control C it, so I'm going to move it into else as well. So I need to check if the score is above 10. Let's see. Math greater than. So if score is greater than 10, I need to grab this. That's the background color, and I'm going to make it pink. So drawing drawer, background, pink. So now let's test it. Run. It's blue right now, as it should be. Let's get a score above 10 and see if it turns pink. So once I get 11, we're already pretty close to, oh no. It's going to take 2 points away for that mess up. There's 10. There it is. Pink background. Sweet. All right. Does it go back? It does go back. That's cool. And we can actually change our rectangle blocks that are making the road as well. But, okay. Put the normal background in the else. Yep, it is. And the new background is in the then. Draw a different background. The score is above that number. Okay, sweet. Finish. Finish. And then randomize enemy speed. Ooh, that's fun. Did you see their score on that? Minus 22? They're terrible. Use random numbers to make some enemies faster or slower. Okay. So create 2 variables to store the speed of enemy 1 and enemy 2. So variables up here. I'm going to say E1 speed and and an E2 speed. Okay. Set the velocity of the two enemies using the two speed variables. Okay, so 2 and 2. When you create enemy... Oh, okay. So I think what I can do is put a random number in each of these. So we'll do a speed of between 2 and 4 for each of them. Maybe even 5. Let's make it a challenge, right? Between 2 and 5. And then when I set their speed or their velocity, and set enemy 1 and set enemy 2, right? Down here, I'm going to use E1 speed and E2 speed. And that should work. It appears to not be working. Speed is still the same every time. Let's see. Setting their velocity. Set enemy 1 and set enemy 2. Reset. Let's see. Why isn't that working? E1 speed, E2 speed. I'm going to pause momentarily and I'm going to investigate why that's not working right. All right, I made no changes to the code, but I tested the program again and it's now working. So to get that to work, create two new variables, E1 speed, E2 speed, or you can name them what you like. That's what I named them. Give them a random number. You can choose your own speeds. I chose 2 and 5. Them does make it very challenging. And then down here inside your set enemy 1 and set enemy 2 functions, make sure you're using that variable label in each of these. E1 speed here in set enemy 1 and E2 speed down here in set enemy 2. And then now you'll see what I mean. See how fast? 5 is maybe too fast. Woo. So now there's, oh, you got past me. Now it's actually really challenging. If I can get a score above 2. Got him. Woo. Nope, that one got by me. Let's see if I can get to 10 here. Dang it. Come on. Oh, no. All right. All right. Now I like it. Now it's actually really challenging and fun. All right. Change the visuals. Change the visuals of the game so that your player, enemies, or cake look different. I'm going to keep mine the same. You know how to change visuals. All you got to do is, replace these with what you like. And then as you do that, make sure that you are getting these animations selected to your new things. And then make sure that down in your move player that you are setting the animation to walking left or walking right down there as well. If you forget how to do that, you can go back earlier in the video or check out previous lessons. You know. But I'm going to leave mine the same. And then end the game. We're going to end the game after 3 enemies touch the cake. So in the game, when 3 enemies get to the cake and print the score, do this. Create a variable that keeps track of how many enemies have gotten to the cake. All right. So I'm going to create a variable up here, and we can call this lives. We'll say 3. And then we're going to use a conditional to check whether an enemy has gotten to the cake. So enemies touch cake. Where are you? If it has, increase your variable. So, increase the variable. So I actually need to say lives. Let's call it something else instead of lives. Let's call it munch 0. And then down here in enemies touch cake, I'm just going by what it's asking me to do here. Use a conditional to check whether an enemy has gotten to the cake. If it has, increase your variable. So here, it's going to be munch gets munch plus 1. Copy that and put it in there. Enemy 2 is touching cake. Use a conditional to check whether the value of your variable has reached 3. Okay, so control. If munch, well, let's find the right math. Let's see. Is greater than or equal to 3. If it has, cover the game with an end screen that displays the final score. I wonder if this needs to be in the. I wonder if this needs to be in the draw loop. Let's see. Just thinking about it right now. Let's stick with this for the time being. We shall see, right? We shall see. Yep. So we're going to make a game over screen. If munch is greater than or equal to 3, then we're going to change the background. Background color, black. And where are we drawing the score? Right here. We'll put show score in here as well. So that makes it a little bit easier. Show score. And we need a game over. So we need to get text on the screen. So drawing, text, game over. And let's see. We're going to put this kind of in the middle. So 130, 170. Let's see if it works. Oh, you know what? I need to change the. Yeah, there's the game over. My score, however, continues. So I'm going to do several things here that it's not even actually asking me to do. I'm going to freeze everything on the screen, or at least freeze the ladybugs, so they cannot continue to go to the cake. Let's see. Show score. Let's get game over to be bigger and more vibrant. So fill color, yellow is fine. And we'll do a bigger text size. Let's try 40. Run it. Get those ladybugs to the cake pronto. We just need one more. We should get our game over screen very soon. There it is. So we need to move that left. So let's try more like 90. Run. Just testing. Whoa. Okay. Run. Just trying to test it, code.org. All right, there we go. Did it not save that? No, weird. Indy. Beginning to think 5 is just too fast. Game over, still too far. 70. But for now, while we're testing, there we go. Game over looks good. And then let's get our ladybugs frozen. So we're going to do sprites, sprite.velocity x, and sprite velocity x. Enemy 1 and enemy 2 are going to get zeros for their velocity so that they cannot continue to get to. There we go. Perfect. However, now cheese it. So we're going to set their X as well to like way off the screen. Enemy 1, enemy 2, 450 and 450. Whoops. Make sure that works. Okay, cool. Now I can't cheese it. So reset, and I'm going to change their speed down here. Oh, actually, I just need to change their speed right here, 2 to 4 instead of 2 to 5, because that's way too fast. All right, now let's, I think that's it, right? So let's finish, and I'm going to go back into it to test it. All right. So let's run it. I've already got a munch. Ugh. 4 is still super fast. Already a game over? Seriously? All right. Let's run it again. We can do better. Maybe not. Can I even beat my own game? Dang. I just want a pink screen. That's all I want. Ugh. All right. Made it way too hard for myself. 2 and 3. Now we can beat this game. All right. I get a peak screen. I'm going to be happy. I've made my Cake Defender game. Works. See, now it's like super easy. But you can make your own determinations on how fast or slow you want this to go. I'm happy with mine. All in all, it ends up being 136 lines of code. But we've got those spacers in there, so it's not really 136 lines of code. But anyway, the Cake Defender game is super fun to make. I hope you had fun making it too. And I hope this video helped you. And if it did, come back and watch the next one for lesson 27. That's our last lesson video for this unit. And then it's the final project for lesson 28. I'll see you back here, same time, same place, or not the same time, unless you watch my videos at the same time all the time. I don't know. Anyway, you guys have a good one.